Welcome back, physics fans. We're going to do Sig Figs here, and it's a method of writing a number which identifies how many significant accurate the measurement value is. So this is about measured numbers, measured values, something that's measured. The number of significant figures is a result of simply the number of figures that are known. The number of significant figures that are known with at least some degree of reliability. Okay, that's what a sig fig is. So there are rules. As you can see coming up here, there's 6 rules. And number 5, it talks about the word 0. Number 4, it talks about the word 0. Number 3, it talks about the word 0. Number 2, it talks about the word 0. So we have 4 rules coming up that all have to about zeros. The first rule is about anything that's not a 0. Okay? So anything that is not a 0 is significant. So these 3 numbers here, 432 or 1.237 or 654,321.123456, these all have numbers that are not zeros. So every number that's written down is significant. So the first one has 3 sig figs. The next one has 4 sig figs. The next one here has 12 sig figs. Simple as that. So anything that is a number that's not 0 is significant. Now we have 4 more rules about zeros, and they are all about where that 0 is. Here is zeros that are surrounded by other numbers. So the zeros in the middle. Zeros in the middle, they are significant. So if you're surrounded by significant figures, you are also significant. So the zeros in the middle, the zeros are in the middle, the zeros are in the middle, the zeros are in the middle, so they are significant. So this 1.007, there's 4 sig figs here. 654,021 point, all those zeros are significant. That's 12 sig figs. And 100.001 is 6 sig figs because they are significant. Now, unfortunately, here comes 2 rules to say when zeros are not significant. So the third rule, so it's different, so I'll highlight it, are not significant, and the next one is are not significant. Where the zeros are. The zeros are in front of numbers. Now this is the weirdest way to write a number, 00402. But if it was ever written that way, the zeros in front of significant numbers are not significant. So that is not significant, that is not significant. Okay, so that gives us the 3. Now here's the one that you're allowed to have the zeros in front, 0.007. But those are in front of the significant number. So those are not significant. So that's 1 sig fig. These are not significant. But again, these zeros in between are significant. So the 10101, that's 5 sig figs. And the 0.9, that's 1 sig fig. Okay, now the next 2 rules are when there is a decimal point. Notice here, there is a decimal point and a decimal point with these rules. Yes, question? Which one are we talking about? Right. Well, the rule says this is significant because that's rule 1, and rule 1 that says that's significant and that's significant. Okay, and then the rule 2 says these are significant. So basically everything here, those 5 are significant. And what you are questioning is now, why are not those zeros in front? Because it's telling us where it's located. Well, if I had to write that in scientific notation, 1.0101 times 10 to the negative 2. These are the ones that are significant. This is just saying how small the number is and how big the number is. So that is not important. This is what's significant. And it's just the rule. If there's a decimal point, but it's still in front, so that rule means that it's in front, it's not significant. Okay, it's just saying how small that number is. So 0.000072 is only 2 sig figs. Okay, the zeros in here are just saying how small it is, but this is their measured value. Measured value is the 7.2. We didn't measure these things. Okay, and we got to be careful because we could change units and those zeros would disappear, but that doesn't mean that they were significant. Okay, just like 22 millimeters is the same as 0.000022 kilometers. But we have 2 sig figs here, we will still have only 2 sig figs there. Okay, excellent question. We're going to go on to number 4. Any zero after to the right. So right now we're doing when there's a decimal point and we're to the right. Okay, and sorry, when there is not a decimal point. So no decimal point. Whoops, this is supposed to, it should not have word wrap. That was bad. No decimal point. When there is no decimal point, they are not significant. Okay, so if there's no decimal point in the number, there's no decimal points here, anything to the right is not significant. So those are not significant. Those are not significant. That one is not significant. So that's why there's only 1 sig fig, there's 3 sig figs, and this will have 3 sig figs. And then the last rule with zeros is when there is a decimal and we're looking at to the right. Okay, so let's take a look at this first one. And by the way, we're looking at that they are. Once there's a decimal, then they are significant to the right ones. So first rule, number 1 says the 5 is significant. Rule number 2, anything surrounded, not in surrounded. Rule number 3, and that's the one that we just spent a little bit extra time on, the numbers in front are not significant. But there is a decimal point here, and the numbers to the right are significant. So those zeros are significant because there's a decimal, and then the zeros to the right, now not to the right of the decimal. 0.0500, this is not significant. But since there's a decimal here, that decimal means the ones to the right of that sig fig number. So that 5 is significant. And anything to the right of a significant number is significant. So that's why it's 3, not 4 in this case. Now, the 1, 2, 3 is significant. There's a decimal. Anything to the right is significant. So that's 4 sig figs. Okay? This one is beautiful. All those are significant. And this rule is saying that this one is also significant, that green one. The numbers in front, rule number 3 says those are not significant. So this is 6 sig figs. A scientific notation, it's just the number that you write down. The number that you write down before the times 10 to the 23, that's what's significant. So that's 3 sig figs. And then this is the weirdest way to write the number, but 3,450 with a dot there, I hate it. Don't ever write that in my class, but if you need to, that's significant. Anything to the right of these numbers. So 3, 4, 5 is significant. There's a decimal. That means this 0 is to the right of that. That is significant. So that is 4 sig figs. The best way to write that, please, is 3.450 times 10 to the 3. Then we clearly know that there's 4 sig figs there. To write that there with a decimal, what happens if your dot is not small enough? It's too small. You've done it in pencil. It's hard to see. That's awful. But there it is, 40.0. That's 3 sig figs. Okay? Now, there's a 6th rule. Counted values are exact. How many candies do you have in your pocket? That's counted, 6. Okay? Anything, those are exact. It's not 1 sig fig. It's exact. And formula numbers and many conversions are also exact. So 15 students, that's exact. What does exact mean? Infinite. Infinite number of sig figs. 1/2 base times height. That 1/2, is that 1 sig fig? No. That's a formula. That's exact. Okay? 100 centimeters is 1 meter. How many sig figs is this? Both of those numbers are exact because that's a conversion factor. Okay? So when you want exact, write down exact. Don't write down infinite. Okay? And now here are some questions for you to try. 21 of them. Try to figure out how many sig figs each of those are and go ahead.